All right, I know we're waiting for some of your classmates, but plan book should be filled out. Notes should be out. A header should be on our notes.
Header, I don't even know her. No? Okay. How about we just do whatever happened?
Whatever happened.
Exactly.
We're doing 722 and 723 tonight. So 722 was technically your homework last night. 723 is technically your homework tonight. I know some of you guys work ahead, some of you guys get behind and then catch up. Because we're going to try to do 2 lessons and talk about a whole lot of stuff.
Oh, that's pretty good. So 1, 2, 2 plus 1, 2, 3.
Any issues from last night? Well, actually, I don't want to ask that question because I want to do the lesson first. I have a feeling that we're waiting for some of your classmates. That or they're on the visit. They're on school visit. I have a hunch. You might want to put that away for the sheer temptation. Not telling you it has to happen. I just have a hunch.
I have a hunch too.
Like a hunchback? Now, Mr. Smith is oh so kindly making some copies for me really fast. Because I forgot to get this stuff taken care of for you this morning. Because a lot was going on, lots of emails to respond to. But while we're waiting for those, let's review what we know about this thing called slope that you guys started talking about in science, actually. Cricket, 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 cricket.
Okay, that's nice.
What? No, you. I was waiting, but.
Oh, you were waiting for. I thought you got a card. So.
No, these aren't yours. I'm reorganizing.
So,
I don't want to put
slope is how a line changes.
How a line changes.
How line goes.
How line goes.
I love how line goes. It's how a line goes. It's how a line does. It's how a line do.
How a line do.
Yes.
Okay. Queen says slope is how a line do. Hold on, let's hole punch these. Come on, you don't want hole punched?
Well,
This is like the least prepared I've been all year. I was trying to do too much this morning. I even got in early in the trading.
Oh, God. Oh.
All right.
Okay.
Anyone else a little better with words, maybe, than how a line do? Great. What is slope? We're trying to talk about this weird thing, slope. Yes, but I might want to switch the screen. Hold on. Brayden would like to draw us a pretty picture to explain this.
Okay, so this is how a line do.
Do you want graph or no? Like, do you want that page or this?
It's just
This? Okay.
so this is how a line do. So
How a line do.
So slope is basically in actual thing that represents slope. You have y equals something like mx. This is really obvious when you calibrate it.
I just did last class. I think you broke it.
It's like, maybe it's the marker thing. Probably not.
You just have to get comfortable with how it's off.
And it's probably nothing.
Okay, so you're giving me a fancy equation, and we're just talking about slope.
Yeah,
Just slope. We're trying to define slope.
N usually represents slope.
That still doesn't tell me what it is.
What?
Still doesn't tell me what it is. If somebody walked up to you, and they were like, explain this idea of slope. Just the idea, like, don't go formal. Don't give them, like technical. I like that you're going deep, but we're trying to start surface level.
Slope is like kind of the angle the line is at.
Okay, that is a good. Okay, so stop there. Well, that can be your contribution. I want to get more. So Brayden's is more formal than Quinn, right? The angle that a line is at.
I know.
I like it. I hear you. We have a class full of people times how many units in the y-axis per the x-axis. You mean like how the scales compare to each other? My question there was a bit dicey. Marin, what do you think?
I think, well, I always do it like there's multiple points and the line, the slope line is like the average of all the points.
Okay.
So like some of the lines might touch it.
What did you guys use slope for in science? What was the point of that? Braylon?
Like measuring mass and volume, you have to like everything.
Why measure mass and volume then? Like, why talk about slope of a mass volume line? Connor?
One certain amount of grams per 1 centimeter.
Yeah, what did that tell us? What were you guys finding in science?
Density.
Density, right? So, the reason we talk about slope is a lot of times we can use that comparison to determine something about an object. What you guys did in science was determining the density of the object, but the first thing we're going to do here is determine the speed of an object. So you guys have your resource page, this, and you have bicyclists A, B, C, and D.
Wait.
722. Yeah, we're going to do this real quick and then probably hop over to 723. You need to be able to present the ranking based off speed. Be careful, speed that the cyclists are riding and back it up with the math that you use. I will warn you, here's how I'm going to do this. I'm going to call on one group to give me the fastest cyclist and the math that supports that. Then the next group will give me the next cyclist and the math to support that. I'm going to give you probably at least like 5 minutes because you got 4 cyclists to compare. We need to figure out who's going the fastest. And there's a couple weird situations with like cyclists A and cyclist B.
Wait, why is that 6-7?
6-7. Ignore that. That's not you. Sorry. You're looking at the smartboard, so I'll minimize this so no temptation. We're just looking at this. Who's the fastest cyclist? Remember, for fast, we talk speed, distance compared to time. Yeah, totally. You got like 5 minutes.
So for A, we're going to do 6 divided by 4, right? And then B is 3 by 9.
So would it be helpful to start to do some math for them? Why can't you just compare with the end? It all stops. The race starts, right? This is there's 20 minutes. Hey, can anyone talk about why we can't just look at how far they go? Like, why can't we just say A wins because he went the furthest? don't know who I haven't checked in with today. Connor?
Well, they didn't start at the same place.
A's a cheater. He started 7 kilometers into the race. He didn't start at the beginning. Look at the shenanigans.
He cheated.
They start at the origin. They start at 0. 0 time, 0 distance. That's how you start a race. Unfortunately, cyclist B had a flat tire. And when they called the start, he was like, I'm still fixing my bike. And he didn't get to start until 6 minutes in. He still started at 0 distance, but he lost his first 6 minutes. So that's why we can't just compare where they land over here. This is not really a fair start. So remember, you're comparing speed, not where they end. Just back it up with math. I'm not saying you're wrong, but back it up with math.
I look at it. Look at it. B is 1. Stop the memorizing. C and U are 9. D. What? Yeah.
Seems like a risky decision here.
Yeah, 3 over 3 is 1. Yeah.
Hear a lot of strong opinions here.
Well, first of all, look at
Alright.
Gwendolyn, and
Okay,
look at
this is not possible.
We have to compare them all equally to each other. Okay. I mean, they're traveling the same speed, right?
Yeah, you don't know.
Who thinks cyclist A is the fastest? Who thinks cyclist B is the fastest? C
Yes, please.
and D? Who thinks there are 2 cyclists going the same speed? Now I start to ask hard.
Hate question. I knew I proved one of them wrong.
Hang on, just hang on. So Peyton, help me with any of it. Whatever you want to help me with.
We think B is going the fastest because comparing all of them per minute, each other cyclist is going about half a kilometer per minute, but B is going 1 kilometer.
So if I look at B, we can go from that point to this point, goes over and up, both 3. So whatever argument was happening in the back of the room about 3 over 3, if we look at the speed there, we have 3 kilometers in 3 minutes. So 1. I don't know. So that's 1 kilometer per minute. We can look up the conversion of what that would be in miles per hour. So I mean, imagine a kilometer is 1,000 meters. That far in a minute. So I mean, that'd be really fast. If you're like, I mean, imagine that's like 100 football fields, right? Or sorry, 1,000. Sorry, 10 football. Yeah, a football field's like 100 meters, right? Close because it's 100 yards. So 10 of those end to end in a minute. Well, you gotta add a little extra because meters are longer than yards. George at the school visit because they keep stealing everybody from me. Marley, help me with anything else. A, C, or D?
Well, I only did, I did first.
Oh. Okay. Well, that didn't work out. Micah, can you help me with another one?
Any of them?
Any of them.
Can I do 2 of them that are in the same?
Sure.
Okay, so they just made the triangle thingy different to, I think, confuse us. But it's on A, it's just twice as big. So 6 divided by 4 is the same as 3 divided by 2.
So Micah's identifying this run of 6, rise of 4, this run of 2, rise of 3. Those are equivalent fractions. Now, they made it look real funky because here they did run then rise. Here they did rise then run. So the triangles look very different, but Micah's absolutely right. Now, the slope of it we know is parallel, but what is the slope, quote unquote, what's the speed here actually?
Oh, 1.5.
It is not.
Oh, no.
Flip it. It's 2/3, not 3/2. You're upside down. So you got to go your vertical change over the horizontal. And Micah, think about this. What you just gave me is minutes per kilometer. Right? Minutes divided by, we don't talk about speed that way. We say kilometers per minute. So guys, these are 0.pad smartboard, 0.66 forever. Right? So 0.66 repeating forever kilometers per minute. So yeah, B's faster as of right now. So then also gone. Quinn, what if we go to do D?
For D, you look at the 4 and the 2 down there. And if you divide 2 by 4, you get 2/4. And then
4.
you scale that down to 100.
Absolutely.
What?
My smartboard's very broken. That's it. So what's happening is 1 or 2 points have gotten in there wrong, and the software can't do what it's supposed to do because a couple points are wrong. So I'll fix that. Questions on finding these slopes? I want to pitch a big old challenge at you then. Flip your paper, find all of those slopes.
This is
Now, here's what's nice about slope. Slope is meant to be presented as a fraction. So you don't have to make it decimal. Here, when we talk about speed, we normally probably use decimals. Some of your parents might have like a fancy car that actually gives you the speed down to like tenths of a mile or your distance, right? We often talk about tenths of miles. When we talk about slope, use fractions. Okay? Dive in. My main goal here is to be able to get you time to do homework, but I got to be comfortable that you're really good at this. Excuse you.
I like having the insatisfaction.
Oh, by the way, I'm going to put this on your next test, but if you continue to give me answers with no labels, they will be wrong. So start to train yourself. Every number gets a label, or you say units, or units squared. You got, so these labels should be something per something. In the first one, meters per years. My advice is draw that triangle like they do here. There's a lot of ways that we can draw it. Small, big, on top, below, doesn't matter. The y over the x. The rise over the run. Do not use decimals. It makes things gross. Now, all we care about right now is slope. But what you should be noticing is some of these start up the y-axis. Some of them start out out the x-axis. So I'm going to start at the origin. None of that matters to what the slope is. Slope, we're just comparing change to change. So, I need to fix this again before we... Sorry, continue. I'm going to try to fix this again.
Wait, no, 2 over 1 is not. Never mind.
2 over 1 can reduce to 2.
Okay, yeah, I reduced it to 1/2 because I wasn't thinking.
You flipped it on accident. It makes a grid so it can sense where, like, think about it. This is not a screen. It's a pad. It's like a receptor for where I'm putting the pen. So unlike a smart screen where the pixels are your detectors, it has to create its own like little grid. Also, so if your screen doesn't take up the whole screen, it can change the size of its grid and compensate with it. You always want to find intersection to intersection. And you can make your triangles as big as you want. This is unnecessary, but don't you think I'm rather unnecessary?
Most of the time, yeah.
So, from a height of 1 to a height of 11, our vertical change could be 10, and our horizontal change could be 5, or alternatively, I bet most of you just did boop, boop. And you got 2 compared to 1, and the slope here is 2 meters per year.
Oh, I wrote it out.
We normally, with something with a Y, put either like a D after it if it's yards, and R after it if it's years. Meters, we can just do M, because MI means miles. For minutes, we just do MIN. So just a single M is what we use for meters. You gotta have a label on these. All right, keep working. I'm gonna give you a few more minutes because I know you got a lot of these to do. I just wanted to make sure we're all on the same page. That's loud. We're gonna turn you off.
That's not very loud.
Quinn, you done with all these? Because I kind of doubt it. So I can look your paper for the very bottom one. You've already got the math written out to show me what the slope is.
Well, I don't have the math out.
So, do that. Trust me. Quinn, do you trust me as a person? So, let's assume that you trust me as a person. I've been where you're going. Right? I've done that math. I've been on the track that you're on. Of, like, you know, kind of accelerated and we're going to get more accelerated. Trust me, get in the habit now of writing out the math you don't think you need to. I know your brain's like, I can do this inside. You're going to start making mistakes. Trust me, write it out.
That's the y-axis.
I thought this person was just like.
Her husband. On 759, what if you thought that a person came from the ground and moved back to the y-axis?
If we have the origin point, you should use it. So when we go through the origin, then pick any other point, and where that point is. Hey guys, I appreciate that you're like kind of excited about this, I think, or there's something buzzing in the air. But either way, I'm trying to give you hints and tricks and things that help. We don't need to make the triangle if we have the origin point, because the math is already done for us. This point existing at 4, 6 tells us the slope. Because to get there, it went 6 up and 4 over. So our slope here, why aren't you smart pen?
Smart pen is not good. Yeah.
Is what? What's our slope?
Yeah.
6 over 4 or 3 halves. Notice what I just told you, Quinn?
Oh, yeah.
Write it out so you make sure you've got. What's my label? 3 halves. Again, meters per year. Fine in all of them. From here out, we're just going to check answers. I don't think we need to do each of them together. So I'll give you a little bit longer, then we'll double check with each other what they are.
Wait.
For 56, what was the label?
See in there?
For which?
It's 3.55 over 4.
Is it 7
The
over
same thing.
8?
Oh no.
Yeah, that doesn't represent a real situation. And 56 is not representing a real situation, so we don't really know what to label. On your test, it should represent a situation. All right, let's check these together. In number 3, moving on quickly, find more people are here. Gabe, what'd you find as your slope in number 3? Like I.
Oh, yeah, okay. Yeah, I found 2/3 for this.
2/3. Do we agree or disagree?
I agree.
Agree. So that line, compared to part 2, they have reciprocal slopes, right? 3/2 compared to 2/3. And people will be tempted to fall into the trap of saying, like, they're perpendicular. They're just, like, one is steeper than the other one. If you compare your 2 to 3, like, now we can make other certain relationships. We could make a perpendicular line, but reciprocal doesn't just do that. In 4, so 3 was 2/3. Chloe, what'd you get for 4? So 2/3. Don't make it a decimal unless you have to. Because 0.66 is not 100% accurate. Even saying 0.66 repeating, that's as accurate as we can get, but it's still not like, so use the fraction when you can. Now, this does not impact it. That would impact the equation, but it does not impact it right now. Jessica, in 56, the one that you said we cannot label, what'd you get there? Sorry, what? 5 over 4. Do we agree or disagree?
Wait, is that equal to 3.5 or am I crazy?
5/4 would be 1 and 1/4. So that'd be like 1.25, but we don't need to make it a decimal. So let's check it. If I follow A, I have up 1, 2, 3, 4, 5 over 1, 2, 3, 4. My up compared to my over, 5 over 4. That's how we get that. Now I had some people like saying some stuff about 59. Caitlin, did you notice anything interesting about 59, or can you give me any information from there? Didn't get to totally fine. Braylon, anything for me? Did you get to 59? T?
When was it in either?
What? What? I don't know, what does that mean? You don't have any, do you need more time?
I have 59 done.
Okay. So, can you give me some information? Whatever you want to spit.
Okay.
Give me A, B, C, something interesting you saw, like whatever you got.
So, for C, I got 3/2.
There's 3/2 for C. There's something wrong with the board on this side. I gotta figure that out. So I go up 1, 2, 3 over 2. Yeah, that makes sense. You want to go more?
Sure.
So I'd say Mallory's next, so the two of you can just knock this problem out.
Okay, so I can do what I did. I just from the first point, like it goes through the origin.
Yeah, makes it easy.
First point off the origin.
Do you have A or B or D? Like D goes through the origin also, right? What's D's slope? 5/4. I don't know what's going on with my small board. It's the bottom point. I think the bottom point went bad. Jessica, you said you have A, or somebody over there said they have A. Oh, Braden.
A is 2.
2? Just straight up 2?
Yeah, it was 6/3, which
So if we wanted to make it, oh wait, how'd you get 2? Because that would mean I should go up 2 over 1 and land at the point like right there. I don't know that I believe you.
I went 16 over 6 minus 10 over 3.
So if we just make a little slope triangle right here.
I hear what he's doing. Okay.
I know, but it'll be the same math above or below.
It wasn't on. There was no 0.
I think you might have goofed up your math a little bit. Go back and check that. A is not 2. Anybody have anything different for A? Connor? A and C are parallel? So A is 3 halves. We go up 3 over 2. Up compared to over. Is that making sense?
B and D are also parallel.
And B and D are also parallel. So 5/4, if I can get my smartboard to let me write it. So wait, A and C are parallel, B and D are parallel. Now, one interesting thing about parallel lines and non-parallel lines, when we start talking about solutions, when we get into graphing, parallel lines have the same slope, right? They either have no solution, like they'll never touch, or what?
They will, it's going to take a little while.
How many solutions?
Infinite one.
They either have none or infinite. Because if they're parallel and on top of each other, the same line, they have every point as a solution. But here, we're parallel and separated, they'll never touch. But if we compare A to B or C to D, A and B's solution is right there. C and D's solution is right there. And then B and C will have a solution somewhere out here. And A and D will have a solution somewhere back here, actually. So when we start talking about solutions, when we're dealing with graphing lines and things like that, that's the point where they intersect. And if I plug the point into the equation, it would be true for both of them. Don't know if there's anything else we need to cover today. All right, if I could find the lesson, that would be convenient. So one thing I wanted to talk about really quick comes partly from your test. When we talk about slope, it can be used to describe physical change that's happening. So this graph is the graph that corresponds to that pattern. Where a pattern begins, what do you think that would be on the graph? Like figure 0 having 2. What is that on our graph?
Y equals 2x, y equals whatever it is, y equals mx plus 2.
Y equals mx plus 2, so that we called, do you know what that vocab is yet? The 2 here is our
base.
Y-intercept. So where we start is a y-intercept. Now the change that's happening, how many am I gaining? 4. Okay. Is it the same here?
Yeah,
2, 6. So this should have 10 total.
yeah.
Okay, so then this, do I gain 4 again? Is this 14? So we can now create a rule and say the number of tiles we need. We start with 2. We got to have 2. But then that growth factor, we haven't been in social studies, it's a simulation. That growth factor makes that our equation.
I saw it on the radio.
So we're gonna keep doing this like a lot, but that's really what we're working for. is we want to define a rule for a situation. So, I know it's a simulation. It's okay. Everything is good. It's just a little bit harder to teach today.
Long live Captain. No, I can't wait for survival.
So if we compare these two situations, we have Thomas and we have Ryan, and this is interest earned, so not total money, right? This is interest earned, how much extra money you have. What can we say? Take a minute, just look at what we have here. Based off what the graphs show us, based off what the tables tell us, I want a volunteer that can give me like a statement based off this. Quinn's been doing everything. Is there anybody else?
You just have to believe.
Quinn, what do you notice up here?
I noticed that whoever, since the graphs aren't, or the tables aren't really labeled, whoever is on the left is gaining more than whoever is gaining on the right, because $1 divided by 2, because that's the amount of weeks that he's earned in that time, is 50 cents. 50 cents is greater than 50 cents.
But the one on the right looks steeper, Quinn.
Yes, that is because he's gaining, because it's...
Hold on, let's let someone else jump in. Micah?
Because the labels on the bottom on the x-axis are different.
Be careful. You can't just say, this line looks steeper than that line. You guys are fine, just send it down. You have to pay attention to how much you're actually changing the values of rise compared to run. This graph's just tighter together. That's why it looks steeper, but it's not. It is steeper on the paper. That doesn't mean it has a steeper slope. So we compare the rise and run. Like Quinn was just saying, $1 divided by 2, that's only 50 cents per week. Whereas here we're 60 cents each week. So Thomas actually earns more. Questions on the fact that you can't just trust your eyes. You gotta actually do the math.
Wait, no, I can't. But what if I can't trust my eyes when I'm doing the math?
You can't just trust your eyes.
Unless you're on the same graph.
And then I think we could do this. Not that you guys have a lot of time for homework, so I have something to pitch at you. Trust me, I have something else. But if we compare slopes, you either have to make them decimals or have what as fractions?
The same denominator.
Same denominator. Hey, Braylon, what did he just say? Yeah, I doubt he was saying shake that white out and annoy Gwendolyn. Because I'm a 7th grade teacher, and I took a job in middle school to, like, not deal with that sort of stuff. But, you know. We either need decimals or common denominators. Okay, if you're going to compare slopes as fractions, which I'm an advocate of just leave it as a fraction, but we need common denominators. I want to give you guys an option for Discovery Day. So you can start packing up if you want, but please do not just start talking because I want to throw this at you. The Math Counts program is bigger than just the competition that we go to. It's a national initiative to get kids engaged in math in multiple different ways. So they have what is called the Math Counts Video Challenge. And to be quite honest, guys, some of your Discovery Day plans that you turned in are lame. Like, not all of them. And some of you have like one good idea and 4 phone-it-in ideas. This is an opportunity for an all-expense-paid trip to Orlando, Florida. And a $1,000 scholarship. So, here's how it works. Brief in a nutshell, and you can Google and find out more information. And I'll probably pitch this at Foundation or Forum. I'll probably talk about this again this week. Teams up to 4 people can make a video up to 5 minutes long. You plan it, you shoot it, you edit it, and then I submit it for you. It must be submitted by March 14th. Then we get people to vote for it, right? Either strangers out in the world say, this video is great, I'm going to vote for it. Or you get your friends and family and everyone else to vote for it. On the website, like you just search Math Counts Video Challenge, you'll find all this stuff. You can read the Getting Started. You can look at the FAQ, which stands for Frequently Asked Questions. This playbook has the problems. Your video has to relate to a math problem in the playbook, but just somehow. And do not think like, oh, it's Math Counts, it's going to be super hard. Guys, some of these are as simple as just an order of operations problem. But your video somehow has to relate to one of these problems. So they're sectioned by, do you want to do a problem in coordinate geometry? And maybe we do something like out on a field or something. Do you want to do just general math? Do you want to do a logic-based problem? Which logic problems are fun. They're like more puzzle-based. Do you want to do one involving measurement? So if you are interested, your 2-day discovery days happen before March 14th. This could be your discovery day of planning, shooting, editing, all of that. And here's the other thing. We're here, your teachers and everyone, on Wednesday, on that first discovery day. So if you needed to come here and shoot your video in school, you could. You'd have like an almost empty building. So put it in the back of your brain if you want. And it didn't have to be one of your 5 ideas you already turned in. We just had to have you turn in ideas so we know you're thinking about it. If you're interested in this, the top 4 teams from anywhere get a trip to Florida, and then you're there at the competition when they unveil who wins, and you get a $1,000 scholarship each. So here's your opportunity. Take it if you want it. Talk to me more later if you want to do that. I'll see you guys. What? Yeah, I might show one of those in formal. It's just like, imagine middle school kids making a video.